Okay, on the test, you will have to know what forms the equations are written. So, you remember standard form is in the form of ax plus by is c. Point slope form, remember the point slope formula. Y minus y1 equals m times x minus x1. And of course, the slope-intercept form is the same as y equals form, which is y equals mx plus b. So think about it. What form is this one? This one is standard form. This one's standard. Okay, so this one is point slope. PS, point slope. This one, is this a form at all? Is this y equals? No, it's not standard because the x and y aren't on the same side. So that one would be just no form. No form at all. Doesn't mean anything. So see if you can write a y equals form equation. Okay, I wrote y equals form, same as slope-intercept form. Y equals means slope-intercept. What I've written is y equals 2x minus 4. So if you had something like that, then you are correct. So be sure and understand this portion of the test. Now we're going to talk a little bit about whether you have a shaded line or a dotted line in a graph. Let's say if you have a y is greater than 3x minus 5. Okay, whenever there's not a line underneath, that means that's just greater than. So if you were to graph it, you would have a dotted line. Okay, so it looks like this is a positive slope, so I didn't graph it. I'm just going to just represent a line here, and it would be dotted. So y is greater than. So since it's greater than, will it shade on the top of the line or the bottom? Will it shade on the top of the line? Okay, and it's dotted. So let me just make up another one. Okay, what if you had something like this? 5x plus, say, 2y is less than or equal to 10. Now, you can graph it and change it to y equals, or you can just use the intercept method and pick your 2 points and determine whether you're going to have a dotted line or a solid line. So I'm going to figure out the x-intercept by making y 0. So when the y is 0, so we know that x is 2. I'm going to go over 2, and I'm going to mark it. So we want to know now when x is 0, that means there's nothing here. We just have 2y is less than 10. So y is going to be 5. 2, 3, 4, 5. So when you do the intercept method, just assume it's equal to. Don't worry about inequalities. Just mark your points. So you know it's a dotted line. So just mark a dotted line here from 5 to 2. Okay. Okay. So it looks like this is going to be a negative slope, right? Because it looks like it's going down a hill. So less than or equal to, that simply means you're going to shade underneath. And am I correct when I'm saying a dotted line, or do I mean a solid line? I mean a solid line because there's a line underneath the equation. So it's going to be a solid line. I'm going to shade it. Now, some of you would like to change it to y equals. Let me change my color. Have the same exact problem, but let's do it in a different way and just change it to y equals. So in order to change it to y equals, I'm going to start with 2y, well, this will be green, 2y, and I move the 5x over because I want it to be y equal, is less than or equal to negative, now it's negative 5x, plus 10. That's already there. Okay, now I'm going to divide everything by 2. And voila. I have y is less than or equal to negative 5 over 2x plus 5. So we know, same problem, same graph. I started at 5, that is our y-intercept. So if I go down 5 and over 2, that's a negative slope, that's the point, still here, same thing. So you can either change it to y equals, or you can use the intercept method. Okay, you will have a problem maybe similar to this, where you have to write an inequality, or not write an inequality, but graph an inequality here. So, first of all, before you can graph it, you need to change it to slope-intercept form. So that means you're going to divide everything by negative 2. So I'm pointing to it. I'm not going to write it all over. So when I divide by negative, don't forget, change the direction of the sign. So now if I'm dividing by negative, I'll have a positive y, and negative 2, negative 3 divided by negative 2 will be a positive 3 over 2x, and I divided a negative 2 into 6, be minus 3. So we graph this, you go down to 3, and you mark it. The slope is positive, so I go up 3 and over 2. So I'm making a heel. Up 3 and over 2. And so I'm just to sort of draw this straight line here. And is it going to be a dotted line? Well, it's going to be dotted because there's no line underneath. So I use my dotted line pencil here. So now it needs to be arrows on both ends, of course. So now I need to determine which way we're going to shade. It's a dotted line. We changed it from less than to greater than because we divided by negative. So now it's greater than. Why is greater than? That means you're going to shade everything on top. Greater than shades on the top. Now you're going to have several word problems very similar to what you see on your packet. Okay, so let's look at the packet and just pick out one that we're going to do. And all you have to do is write the situation. So Mark wants new school supplies. Let's see if we can do this one. He will buy pencils for 0.25. So I'm going to put 0.25p for pencils. And paper tablets, which is T. You're going to buy both of them, so I'm going to add it. It'll be 1.5 for T, for tablets. And in the situation, it says the cost of all school supplies needs to be below. The cost needs to be below $10. So it's less than $10. Does it need to be equal to? It didn't say equal to, it says it has to be below $10. So this situation, there is not a line, and this is the inequality that represents it. And make sure you understand these type, where you have a graph. Let me get my pen right. And you have the questions. So let's first write an inequality to represent the situation. So read the question and go ahead and tell me what equality you would write. I would write the club makes a profit of 25 cents per candy bar, so 0.25C, and 50 cents for a sour punch plus 5. This is really hard to write with this mouse. And I'm going to say this is P. And it says it needs to make a profit of at least. So this needs to be $100 or more. So this means greater than at least $100. That means it can be $100 greater than or equal to $100. Okay. So now let's graph it, and it tells you the number of candy bars. Okay, here, and the number of sour punches here. So C is the candy bar and P is the punches. So we can use the intercept method again by just putting 0 in for, let's say, C to figure out what P is, and a 0 in for P to figure out what C is. Okay, I've already did the calculations. So when I made C 0 divided by zero point 0.5, I'm going to get 100 divided by zero point 0.5 will give you the P is 200. So I'm going to mark 200 for the P. And for the C, I made this 0 divided by 100 by 0.25. And this is 400 for the C. Now we know it has to be at least 100, so it can be 100. So we're going to make this a solid line. Now greater than, so we know our shading will be above. Let's look at our questions. Is 200 and 100 a part of the solution? So we go over 200 here and up to 100. Looks like it's right on the line, okay? So if you want to be sure, just put the value in, put 200 in for C. So you have 200 times 0.25, and that's 50. And then we're going to put 100 in for P, 100 times 0.50, oops, 100 times 0.50, can't type today, 100, this last time times 0.50 is going to give us 50. So we know 50 plus 50 is 100. So this is a solution because it equals 100. So this is yes because it equals 100. And now it says it's 250 and 100 a part of the solution. So if I went over 250 and went up 100, it's right on this side. It's in the greater than side. Yes, it's also a part of the solution because it is on the side that's shaded. That's what the solution is.